Hello students, welcome to the embedded system concepts. So in our chapter we have 5 units. In first unit it is introduction about embedded system. In second unit we are going to study about embedded processor architectures, different types of embedded architectures, processors. And in third unit we are going to study about overview of microcontroller and embedded systems. And in fourth unit we are going to study about microcontroller fundamentals for basic programming. In fifth unit embedded communication port protocols and IoTs. So coming to first unit, in this lecture I am going to give the introduction about embedded systems, right? So these are the first unit topics: embedded systems and definitions of an embedded system, characteristics and classifications of embedded systems, and different applications of embedded systems, host and target concept, features and architecture considerations for embedded system, embedded processors and their types, memories whatever using in embedded system, design process of embedded systems, and programming languages and tools for an embedded systems. These are the first unit topics. So coming to embedded system, what is the definition of an embedded system? So mainly embedded system is an electronic or electromechanical system designed to perform a specific function and is a combination of both hardware and software. This is important. So right, what is an embedded system? Embedded system is a combination of hardware and software, right? So and embedded system it will perform a unique task. So embedded system is a hard combination of hardware and software which will execute or which will perform a specific function. So the program instructions written for embedded systems are referred to as firmware. So we can call embedded system as hardware, combination of hardware and software, or hardware and firmware. So firmware is nothing but firmware is a software code which is going to debug in hardware of an embedded system and are stored in random access read-only memory or flash memory. So we can call embedded system is a combination of hardware and software where the program is stored in RAMs. Okay, so and every embedded system is unique and the hardware as well as software is highly specialized to the application domain. So what is meant by application domain means any embedded system will perform a unique operation, like washing machine, we use washing machine for washing the clothes, like microwave oven, we use microwave oven for cooking. Like this, any embedded system can perform a unique task, right? Embedded systems are designed to do some specific task rather than a general purpose computer for multitask. We use our the computer for multiple tasks, like we can take a print, we can scan a paper, we can watch online games, we can browse. So we can have many tasks in general purpose computer, whereas embedded systems are used to perform a unique task. So next, characteristics of embedded system. So every device definitely will have some characteristics. So in our embedded system also has some characteristics. So first one is application and domain specific, reliability, reactive, real-time performance, low power consumption, and sixth one is operates in harsh environments. So these are the characteristics of our embedded system. So coming to first one, application and domain specific. I explained earlier also, a embedded system is a combination of both hardware and software, and it is meant for perform a unique task. So it is a application specific domain. Application specific. And what is meant by domain means, so we have mainly 6 types of domains. So in embedded system, hardware we can use microprocessor or microcontroller, or for VLSI we use CPLD or FPGA, and for for signal processing we use digital signal processor and ASICs. So application means it will perform a unique application, and domain specific means we have different types of domains like microcontroller, microprocessor. We use any one domain. For example, we can't replace the embedded control unit of microwave with air controllers. It's 100% true, right? We cannot change microwave control unit for air controller. So characteristics of embedded system, first one is application and domain specific. So second one, reliability. We can purchase a washing machine for a long time. So this is main, whatever the embedded systems we are going to purchase, so we can use that embedded system for long time. So mainly any embedded system can have a major characteristic like reliability. Embedded system have to work for thousands of hours without break. This call for very reliable hardware and software. For example, if the embedded system comes to a halt state due to hardware error, the system should reset itself without any human interaction. So reliability is a measure of how much percentage we can rely upon the proper functioning of the system without failure. So this is a major characteristics of embedded system. So third one is reactive. So embedded systems are in constant interaction with the real world through sensors and user defined input devices. Any changes happening in the real world are captured by sensors, it will react to the real world. So hence embedded systems are referred as reactive systems. So next one is real time performance. So mainly we can use real time embedded systems, so which depends upon time related. So real time embedded systems are two types. First one is harsh real time, second one is soft real times. So in real time embedded system, a specific job has to be completed within a specific time. So they have two time constraints and they have to work against some deadlines. So those embedded system depends upon real time, means depends upon time, or comes under real time performance embedded systems. And if at all, a real time should not miss any deadlines for task operation. For example, in a nuclear platform, in a nuclear plant safety system, missing a deadline may cause loss of life or huge damage to property. Hence, in hard real-time embedded system, which are subject to very strict deadlines for performing specific tasks, the timing analysis is of great importance. So, real-time performance also a characteristics of embedded systems. So third one is low power consumption. It is very important. Most of the embedded system operates through a battery. To reduce the battery drain and to avoid frequently recharging of the battery, the power consumption has to be very low. So whatever the embedded system we are purchasing, it should be a low power consumption. And hardware design must be address these issues, for example by reducing the number of components, by designing the processor to revert to low power mode when there is no operation. So in embedded system we have number of blocks. So whenever one block is not in a functioning mode, we should be set it as sleep mode, so that the power consumed is very less. So sixth one is operates in harsh environment also. Some of the embedded systems are to be operated in harsh environment conditions like high temperature zone where a human being cannot survive for long time, areas subject to vibration and shock, etc. Systems placed in such areas should be capable to withstand all these observed operating systems. So where the human being cannot survive for a long time, there also our embedded system can work. So it should be operates in harsh environment also. These are the different characteristics of an embedded system. So first one is application and domain specific, second one is reliability, third one is reactive,